Gary Cooper. We'll be talking about the test and debug work group within MIPI Alliance.
Actually, so while we're looking for the presentation, I'll put a caveat that I was going to put in anyway, in the fact that we're called the Test and Debug Work Group, but this is one of those things, and I'm sure you've all seen it in your own companies or organizations. It was named a long time ago and doesn't quite reflect what we do. We're really the Debug Work Group, but it was called Test and Debug 7 years ago when it was formed, and that stemmed from the silicon test and debug in the traditional vein of it going through the 1149.1 JTAG interfaces. Okay, so we actually do play at the interface level, but we play at lots of levels, but you'll see here that this gigabit trace and 1149.7, which although is no longer a MIPI specification for debug, it started here. So we do play on the peripheries here, but we play at lots of levels. So this is sort of this, pie in the sky table for all the things that we're going for from a debug capability. Everybody wants us debug footprint to have fewer pins. They want it to be faster. They want to have industry standards, so tooling and chips, debug tooling and chips can play together. And all of the other, scalability, all the other the fine words that people use, but those are some of the key points that we're shooting for. And the idea of being within the MIPI space, that since there are intelligent agents in many different parts of a modern smartphone and such, that the debug is spread across multiple parts of your system, so it's quite useful for all parts of like a smartphone system or any kind of intelligent mobile system. So we obviously have a charter and scope. The charter is probably not really useful to go through in any detail, but the scope is, what we're trying to focus on is, things that start very simple. As simple as the mating connections, which standardizing on those for connecting the tooling to the systems that are being debugged, the pin assignments on those connections, the timing characteristics of those interfaces, but then moving a little bit deeper into the chip, where some of the protocols used across those interfaces, the debug-specific protocols used, and then even expanding further into a system-wide debug approach. And I think you'll see that we have a system block diagram where we build from the basic interfaces here, the board connectors. So we have a document that specifies a series of connectors and the pinouts for them that go from a very simple basic connector that allows you to do standard debug as you would imagine run control debug and some very low bandwidth simple trace, to a board connector that is a very high performance connector that supports a very wide parallel trace interface and very high speed. And so then when we start to move a little bit deeper in, we have more specifications that we developed. So we have what we call the parallel trace interface. Okay, and this is actually the timing and the timing and protocol format for the parallel trace interface. We're working on what we call the gigabit trace effort, which is where we're going to reuse the high-speed serial I/O interfaces like MFI, the MIPI MFI, for debug, and sitting on top of Unipro in that case, which you've heard about today as well. We also have an effort called NIDET. It stands for Narrow Interface for Debug and Trace. And this is a specification that defines how to remap debug interfaces over other functional interfaces in your system, so that if you have a removable memory card, you can actually turn that into a debug port that you can connect your tooling to. Then we move another layer deeper into the chip. Okay, so we have some protocols that we've defined that work at the trace interconnect level. We have the system trace protocol and the trace wrapper protocol that define how different debug sources can be used, can have their data managed and merged together so that they can flow through the system. And then we move all the way up to the top level where we're playing with software in the fact that this open system trace is defining a framework for standardizing software messaging within systems, so that you have a standard model for protocols, for message protocols for people that like to instrument their code. So this is just the listing of some of those things because they were abbreviations before. So you'll see parallel trace interface, PTI, things like that. This here is actually that high-speed parallel trace connector that I talked about that we've standardized with a pinout. So we do also play, we're not alone. Debug is certainly not in a vacuum. So we have to be aware that there are other organizations that do this kind of thing for standardization. One of the biggest ones is the Nexus organization. And they have a broad scope just as we do, and we've worked with them to try to avoid collisions, but their space is strictly automotive. Mobile's and MIPI's purely mobile, and so even though we've worked hard to try to avoid collisions, but some of those do occur. Some of the other things that people are obviously familiar with, the ARM core site architectures. ARM is a major player in MIPI T&D, and in the places where we overlap, we've done a very good job of making sure that we stay standard. The TWP specification and STP 2.0 specification were developed in conjunction with ARM, so there is no collision in that space. 1149.1, the traditional JTAG interface, is comprehended completely within MIPI T&D, and the 1149.7, the enhanced JTAG, that is the 2-pin interface with a bunch of other features, was a standard that was actually initiated as an effort within the MIPI Test and Debug work group, and then spun out into a separate IEEE standards committee for several reasons. But in any case, we are obviously completely compatible with that because it really was originally a MIPI effort. So I'll quickly go through the timelines. We have a lot of specifications that have already been released. The system trace protocol specification, the first version of PTI was in 2007. The debug connectors, a base protocol for the open system trace, an updated version of the system trace protocol specification is no longer in final review. This is actually approved by the board as of last Friday, but these slides were in before that approval came in. And the trace wrapper protocol specification, the TWP, was also approved last week. And this year we also expect an updated version of the PTI 2.0 to be released. We have several things on the roadmap. A Debug architecture overview, which is a blanket document that pulls in all this stuff because it's kind of disjointed unless you have an overall document to bring it together. I talked a little about the 9-int effort to remap debug over functional interfaces. The gigabit trace. These two specifications will provide us this. Well, these three are the gigabit trace family. So this is how to do trace over the high-speed serial I/Os, and then the open system trace framework, which is the top-level software view for people that want to instrument their code. So to finish, the contributing companies are ARM, Intel, Lauterbach, Qualcomm, ST Ericsson, and ST Micro and TI. My name is Gary Cooper. I'm the chair of the group. The vice chair is Jigang Yang from Nokia, and we get some program support from Glenn Hambro. We have quarterly face-to-face meetings and a bi-weekly conference call, and as you can see from our timeline, we have several specifications at different stages of the pipeline at any given time, and it can be challenging, but it also doesn't get boring because you can switch to looking at something else.
That's great.
So
Thank you.
that's it.